And now I want to introduce the next topic to you. It's blueprinting AI services for big data analytic. And I want to welcome on stage Shehide Abuliz from Allianz and Julia Gschwendtner from Allianz as well.
Thanks.
Shehide, you are a senior IT professional and responsible for preparing AI-based applications for production, ensuring their reliability, scalability, maintainability, and adaptability to evolving business needs. And Julia, you have an academic background in mathematics, and currently you are working as a business analyst in the AI ML team at Allianz, Kunde, and Markt. So, also for you, 19 minutes, and stage is yours.
Thank you. Welcome to our speech. My name is Shehide Abuliz. This is my colleague, Julia Gschwendtner. We are from Allianz Technology. We are from a DIA tribe. It is data insight and analytics tribe. We both work on AI ML team. We are responsible for designing and building data infrastructure platform, and also at the same time we host and maintain several AI services. So therefore we want to show you how we blueprint our AI services in this speech. The landscape of AI has changed a lot in recent years, thanks to the great libraries like FastAI, Hugging Face, PyTorch, and TensorFlow, which made building an AI model quite easy. However, to really make a product that use AI to make certain recommendation, for instance, recommending our customer the right insurance product, or the classic case is fraud detection or money laundering detection. This is hard. This is what we go through every day. Let's big data, where the fun start. Usually the full-fledged production-ready products are arise from small POC project and evolved from it. Such project usually just have small database, and this was really fun for me as a data scientist, how I just do data exploration and analysis and play with, do some feature engineering, and I can just play with pre-trained large language model or stuff, and testing out different models, evaluating them. This is fun. However, within the enterprise, you will quickly face some challenges. In my opinion, this is mainly due to two causes: large data volume and working in collaboration. So pre-cleaning and pre-processing large data can be very time-consuming and computational intensive. And model training time would be very long, and deploying such model on production system is also very complex. Sometimes you need data analytics occur in real time or near real time. For this, you also need to have specific solution. And this is all very costly, money-wise and time-wise. Another problem is working to keep the consistency in the computing environment. For instance, your colleague have different libraries, packages, configuration. This will cause compatibility issues and inconsistency conflicts. And sharing GPU, CPU among multiple users can lead to competing for limited resource, can lead to content, and this could slow the process. So collaborating with other data science and collaborating with even a cross-functional team could be very difficult. However, nevertheless, I still give us 10% to go, just for the sake of our data science knowledge. And my colleague might give you some solution for the problems I have mentioned above, and tell you how we bring people work together.
Yeah, thank you, Shehide. Also, welcome from my side. At the beginning, we already said we have our data. We might have some ideas. Now we want to really get working. So Yeah, okay, now it's better, thank you. And how can we start to work? Like, where can we work? We want to collaborate, we want to work with different teams together. Where can we do that? We need a platform. And actually, what I think is quite cool, our team created our own platform. So we have our own machine learning platform where all our data scientists can work together. Why did I choose the house? Because I really like to think about this as a home base for our data scientists. It is an everything as a service cloud machine learning platform. We call it data science workbench, and I will just introduce quickly what you can do with it and some key facts about it. No, second. Sorry. So you have one single landing page on the data science workbench. It is the Jupyter Hub. And then you can customize your own environment. So you either would prefer to work with R or maybe Python. So you can just work with RStudio or the Jupyter Lab. And then also, as Allianz has a lot of data, but for us, the security issues, they are really important. We value them a lot. So what we tried to do is we integrated some data sources to our data science workbench, but most importantly, not only in easy access, but also in secure access to keep all our data safe. Then we have some machine learning tools integrated. We always try to, we're still working on it. There are always new coming, also new features we might have to integrate. And then also we give individual use case support. So we have platform engineers and they really try to help our data science to make the best out of our data. So I would say, we're at 25%. We can really start the data science work and we can create and maintain use cases. We can collaborate with teams. We can share our group buckets, share repositories on GitHub, use all the data analysis technologies. Hugging Face transformers, just to name one, and also develop, train, and validate our machine learning models. As I already said, we also provide individual use case support. This, for example, we have a help channel where our data scientists can ask if they have some problems and we need to do some bug fixing, but also our onboarding process, for example, is quite complicated, I would say, because we need to have a very secure onboarding process and we also provide support there. And then still, we're still trying to understand what do our data scientists need, like what features should we implement. We're holding a big open mic session where we ask how happy you're with your work on the data science workbench right now. Are there any features we're missing? And then we always in our team try to prioritize the next features we might have to integrate into our workbench, but then also, about like cost aspects, what our options are, and then, optimize our platform accordingly. Just to give an example, we just integrated Apache Spark for every use case. And what we plan right now is also to kind of integrate Amazon SageMaker. We still want to customize our workbench, like do a lot of fine tuning ourselves. So Amazon SageMaker won't substitute our workbench, but we try to get like a solution in between.
Okay, let's talk about the landscape of AI model development process. So as I talked before, model development has become easy thanks to all these amazing open sources and also similar on the R side. However, one character of ML model is that you need to continue to train them to improve your model performance. For this, we have incorporated CI/CD pipeline into our team. CI/CD is continuous integration and continuous delivery. This will help us to prevent lots of manual intervention. It will help us to deliver code change faster and reliably. And we also use Luigi pipeline, which is a workflow management tool to help us with this CI/CD principle. And another thing about there are multiple ways to deploy your model. You can mount it to your Docker container. However, we have faced lots of problems with that in terms of debugging. So our way to deploy model is to deploy it as a standalone service within REST interface. This decouples the service model from the rest of the service, and you can change the model, or you can change the algorithm or scale up the model whenever you want. And last but not least, we need to create more visibility around model. We need to know where is the model running, how is it running, which version is running currently, which was the previous one, so that we can even revert to the previous one if needed. This is this model management and model governance. This is very important. Yes, Allianz is a financial service provider company. We need to follow lots of strict regulations. So for these cases, we need to combine business rules with ML model. We use Camunda as our workflow management system, which is an orchestration engine. It can process complex workflow across people, systems, and devices. It is an open architecture, easily integrated with microservices architecture and event-driven architecture. It also is a visual collaboration. It makes visual collaboration between IT teams and business stakeholder easier. It has very powerful connectors. You can connect basically everything into the workflow, including your database, your REST services, your microservices, even legacy applications. This is just a snippet of our Camunda workflow. You can see up there, there is a ML model deployed. And here you can see the classical case where what do we do if the model accuracy and confidence is not high enough, then we go through that path. If so, we go through other path. And we also integrated, we can also do SQL query. And at the bottom of the picture, you see there we call some REST services. So we have talked about a lot of things here. However, still a lot of topic we haven't covered. For instance, DevOps, deployment, monitoring, optimization, and so on. We can only close this ring with our MLOps. MLOps is an essential discipline that you instill into your organization. It combines DevOps and machine learning. It delivers product faster and reliably. It also promotes shared understanding between data scientists, data engineer, DevOps teams, and business stakeholder. It helps us with continuous improvement and the transparency and accountability. So this is the MLOps cycle. As you can see, it is infinite cycle. We go through it every time when we do this iteration. This is how we bring a product from ideation to production. The first step is always the planning. We use Jira. And the second step where we create this product with our DSVB. But if you are a smaller team, you can also just use Jupyter Hub. And then we package it with Docker. We release it with Jenkins, and we configure our infrastructure and service with Kubernetes. In case if you have live streaming data, then you will need a message broker, which is Kafka, and we monitor it with Grafana and Prometheus. Yeah.
Thank you. And yeah, I think now we reached a point where we can really maybe give you some examples of what we're doing in Allianz. And we want to present one use case. It's called lead rating. And I will just quickly introduce what it's about in a very simplified way. So what are we doing in Allianz? Yeah, we are doing something with insurance. And you can maybe imagine now that there's a man who would like to get an insurance. I really like cats, so you can imagine that this man, maybe called Sven, has a cat and wants a health insurance for his cat. So if there are very expensive operations, Allianz would cover the costs. But then we, in the business term, we call this a lead. And then we don't only have the lead, so the interest in the insurance, but on the other side, on the right, you see that we have some agencies. Agencies, they have subscriptions with Allianz and want to sell our products to our customers. And what this use case is about, it's about the routing of the lead, the interests. Sven might not know which agency to choose, which agencies has the right insurance for him. So this fitting problem we're solving in this use case. So you can already imagine that geolocation plays a big role in this, because we don't want to give Sven an agency in South Germany when he's maybe a bit more northern. And then hopefully we find the right agency that can provide Sven with the contract he wants, the insurance he wants to get. But this is very simplified, and we have live data of the lead in the use case. We also have the geolocation, but also the whole portfolio of Sven's requests, and then also all the agencies with the different subscriptions. So it's very complex. And why are we presenting you this use case? Because that's exactly what we do. We followed the whole MLOps cycle, like the complicated way, from planning the use case, from developing machine learning models on our data science workbench, then doing like also implementing them, deploy them, and also do the monitoring. And what you can see here is on the top is the Camunda process of the global solution. And you actually see it's a bit more complicated than I just explained it to you in my little drawing. But we use Camunda to combine the business rule and also the models I talked about. And why global solution? Yeah, because what is also cool about the use case, it is not only applied in Germany, but also in France. Some other countries are also planned, but maybe let's keep it with them too. And why do we have the global solution? Yeah, because it would be so much work to start from new in every country. Like we have some business rules, some models that we can use as well as in Germany and in France. So we need a global model. And that's what you see on the top in our Camunda process. But then there might be some, you maybe also know it, when you're in a different country, there might be some regulations that are a bit different. So to also take account of those differences in regulations, we need also to do the fine-tuning of our local process. And that's exactly what you see right here. Like this is the moment where our global lead rating model calls the local lead rating process, in this case for Germany. And that's, so we're ready now to integrate our local processes with the global one. Just to give you at the end one example what differences there could be. So I told you geolocation plays a quite important role for our lead routing. And in Germany, our geolocation is measured by air distance, whereas in France, it is measured by street distance. And yeah, so they both have some advantages. Just in Germany, we really hope that there is not a lake between the agency we route the lead to, because then the way around it would maybe take a little bit longer. And in Sven's case, that's not the case. So he finds a fitting agency, hopefully gets the right insurance, and then can have some health insurance for the cat. So this was our example of an actual use case that follows our whole blueprinting of AI services. And we really hope that you got maybe some insights of how we're applying use cases with AI services in Allianz, and maybe also for your own projects, you could get some ideas. Thanks so much.
Thank you.